of x is given by this algebraic fraction, and we're asked to essentially find the derivative, show that it's in this form. So you could write this as a product by writing 2x minus 3 times x squared plus 4 all to the minus 1, and then you could use a combination of the product rule and the chain rule, but as soon as you see a fraction like this, you want to be bringing out the quotient rule, in my opinion, so I'm not going to go through it in any other way than the quotient rule. I'm not a fan of the quotient rule written in this form. I always use u and v, but you can just swap them round, so it's not a big deal. I'm going to say that this is u and this is v, and then u dash x, I'm just going to write u dash is going to be 2 when I differentiate the top, v dash is going to be 2x. So that means f dash x is going to be u dash times v minus u times v dash all over v squared. So I've got this bit sorted. I just need to simplify the top, write it as just a quadratic in a slightly nicer form. Let's expand. So we're going to get 2x squared plus 8. Then I'm going to, no, I can just multiply it out. It's okay. 2x times 2x is 4x squared. Then I've got the minus. It'd be minus 4x squared. And then minus 3 times 2x is minus 6. But then I'm doing minus. It'll become plus 6x. Then I'll get minus 2x squared plus 6x plus 8 all over x squared plus 4 all squared. That was the form that they asked for. Hence, using algebra, find the values of x for which f is decreasing, showing every step of our working. So if a function is decreasing, as x increases, y is decreasing, it's going down. And the only way this can be true is if f dash x is less than 0. That's our condition for decreasing. So we're going to solve f dash x less than 0 for all x, which means minus 2x squared plus 6x plus 8 over x squared plus 4 all squared is less than 0. So the denominator is always positive. Actually, it can't even equal 0 in this case. Yes, always positive because it's going to be a square of something. So I can times through by it. If it could be negative, we have to think about things more carefully because the sign would swap around when you times through by a negative. Basically, it must be that the numerator is less than 0. That is what's making this fraction negative. Now I've got a quadratic. So I'm gonna do two things. I will take it steady. I'm gonna just times through by minus 1, which changes the sign around. Or equivalently, you could add 2x squared onto both sides, minus 6x and minus 8. Then I'm going to divide through by 2. And you could just have put this in your calculator to be fair and solved it, but this one will factorize. So it's always good to practice your quadratic inequalities through factorizing in case you're asked to show detailed reasoning, etc. So I'm going to get minus 4 and plus 1. Times is to give minus 4, adds to give minus 3. Always get a little sketch down. This is my advice. So our roots are going to be 4 and minus 1. Quadratic is going to look like that. We're interested where it's greater than 0, so it's going to be this side and this part of the graph. Remember, I'm actually plotting y equals this thing here, and I'm looking for where y is greater than 0. So x must be less than minus 1, or x must be greater than 4. Those are our range of values of x that would lead to a decreasing function.